May 4, 1945. 200 miles west of Bergen, Norway. Through the periscope of U-2511, Corvette Captain Adalbert Schnee watched the silhouette of HMS Norfolk cut through the grey Atlantic swells. The British cruiser, 10,000 tons of steel and firepower, steamed in formation with her destroyer escorts, unaware that Germany's most revolutionary submarine had closed to within 500 meters. Schnee's hand rested on the firing solution calculated by his crew. 6 bow tubes loaded. Hydraulic reload system ready to fire all 23 torpedoes in under 20 minutes. The Type 21 could attack and escape at 17 knots submerged, faster than most surface ships could chase. For the first time in 3 years, a German U-boat commander possessed technological superiority over the enemy, but Schnee would not fire. 4 hours earlier, he had received Admiral Dönitz's ceasefire order. The war was over. In his log, he recorded the approach as a practice attack, demonstrating what the Elektroboot could have achieved. Then U-2511 turned away, her presence undetected, and headed back to surrender. The revolutionary submarine that was supposed to win the Battle of the Atlantic had fired 0 combat torpedoes. 118 Type 21 boats had been completed. Only 4 were combat-ready when Germany surrendered. Only 2 conducted patrols. Neither sank a single Allied ship. The wonder weapon that German admirals believed was unstoppable arrived too late, too flawed, and too overwhelmed by the industrial and technological advantages the Allies had already secured. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how Germany's most advanced submarine became a monument to wasted resources and desperate hope begins not with the Type 21's failure, but with the catastrophe that made it necessary. May 1943. Black May. In 31 days, Allied forces sank 41 German U-boats, 25% of the operational fleet. The exchange rate that had once favoured submarines 50-1 had reversed completely. Admiral Dönitz, newly appointed Commander-in-Chief of the entire Kriegsmarine while retaining direct control of U-boat operations, watched his carefully constructed tonnage war collapse into an arithmetic nightmare. U-boats were being destroyed faster than shipyards could replace them. Crews were dying faster than training schools could produce them. The Atlantic, which had been a hunting ground in 1942, had become a killing field where every patrol meant probable death. On May 24, 1943, Dönitz made the most painful decision of his career. He withdrew U-boats from the North Atlantic, effectively conceding defeat in the campaign that was supposed to starve Britain into submission. The telegram sent to all boats at sea was brief but devastating. Due to superiority of enemy location equipment and overwhelming air coverage, North Atlantic operations are temporarily suspended. All boats currently operational are to withdraw. The word temporarily was self-deception. Everyone from Dönitz to the youngest rating understood that without revolutionary changes in technology, the U-boat campaign was finished. The numbers told a story German leadership struggled to accept. In 1942, U-boats had sunk over 6 million tons of Allied shipping. By May 1943, American shipyards alone were producing merchant vessels faster than the entire U-boat fleet could sink them. The 2,710 Liberty ships would dwarf Germany's submarine production. Allied centimetric radar, installed on aircraft and ships, could detect surfaced U-boats from 20 miles away in any weather. The cavity magnetron technology, captured from a downed British bomber, in February 1943 had revealed why U-boats were dying. Germany's radar warning receivers were deaf and blind to the electromagnetic frequencies the Allies exploited. U-boats ran on the surface at night, trusting METOX detectors to warn of approaching aircraft. But the detectors could only sense radar operating at 1.5-meter wavelength. Allied ASV Mark III, radar operated at 9.1 centimeters, 17 times shorter. Aircraft appeared without warning, bombing U-boats whose crews believed they were safe. The technological surprise was complete and irreversible. When German scientists examined the captured magnetron in Berlin, they performed an autopsy on submarine warfare. The copper block measured barely 10 centimeters across. yet generated 40 kilowatts of microwave power at frequencies German engineers had declared impractical for military use. It was elegant, sophisticated, and completely beyond Germany's ability to mass-produce given material shortages and Allied bombing of industrial facilities. The realization was crushing. If Britain, suffering under years of strategic bombing with its industrial base under constant attack, could develop revolutionary radar technology superior to anything Germany possessed, then every assumption about German scientific superiority required re-evaluation. More critically, if the Allies could deploy such technology at scale across hundreds of aircraft and ships, then conventional U-boats had become obsolete. They were visible to enemies they could not detect, hunted by weapons they could not counter, forced to operate in an electromagnetic environment where the enemy possessed complete dominance. Dönitz needed a solution immediately, but the laws of engineering and physics were unforgiving. Conventional U-boats spent most of their time on the surface, diving only to escape detection or make attacks. They were essentially surface ships that could submerge temporarily. This made them vulnerable to aircraft radar, regardless of weather or darkness. The snorkel, a Dutch invention captured when Germany overran the Netherlands in 1940, allowed U-boats to run diesel engines while submerged at periscope depth. But snorkels were slow to retrofit, limited speed to a few knots, and left a wake visible to radar in calm seas. They were a partial solution at best, improving survival without restoring offensive capability. What Dönitz needed was a true submarine, a vessel designed to operate primarily underwater, spending only minimal time on or near the surface. A boat with sufficient battery capacity to transit submerged for days. A hull form optimized for underwater speed rather than surface performance. Weapons systems that could attack and reload while remaining deep. Such a submarine could evade Allied radar by staying beneath the electromagnetic horizon. It could outrun surface escorts while submerged. It could transform submarine warfare from increasingly futile surface attacks to genuine underwater predation. The technology required was not theoretical. German engineers had been researching advanced submarine designs for years, though none had been pursued with urgency, while conventional U-boats seemed to be winning the tonnage war. The most radical design came from Professor Helmuth Walter, who had developed hydrogen peroxide turbine propulsion, theoretically capable of 25 knots submerged. But the Walter boat, designated Type 18, was extraordinarily complex. The hydrogen peroxide fuel was highly volatile and flammable. The turbine system required maintenance beyond the skill level of average Kriegsmarine ratings. The fuel supply chain was uncertain. Most critically, development and debugging would take years. Dönitz didn't have years. He didn't have months. American and British shipyards were launching merchant vessels at rates that made the entire concept of tonnage warfare meaningless. Allied radar coverage was expanding daily. Soviet forces were advancing in the east, threatening Baltic training grounds. The Third Reich was losing on every front, and only immediate deployment of revolutionary submarines offered any hope of disrupting Allied logistics sufficiently to force negotiated peace rather than unconditional surrender. The solution emerged from a compromise between revolutionary ambition and practical necessity. Take Professor Walter's streamlined hull form, designed for high underwater speed, but eliminate the exotic hydrogen peroxide propulsion. Instead, install conventional diesel-electric engines with triple the battery capacity of existing U-boats. This would provide extended underwater range and high submerged speed, without the complexity and volatility of the Walter system. The result would be fast enough to challenge surface escorts, while remaining technologically achievable within Germany's constrained resources and timeframe. The design that emerged from these constraints was designated Type 21, though crews would call it Elektroboot, an electric boat, acknowledging its revolutionary power systems. On paper, the specifications were extraordinary. Length 76.7 meters, displacement 1600, 21 tons surfaced, 1819 tons submerged, maximum surface speed 15.6 knots, maximum submerged speed 17.2 knots, more than double the 7.6 knots of conventional Type 7C boats. 6 bow torpedo tubes instead of the standard 4. 23 torpedoes were carried. Hydraulic reload system, allowing all 6 tubes to be reloaded in 10 minutes, less time than it took to reload a single tube on conventional boats. This meant a Type 21 could fire 18 torpedoes in under 20 minutes, devastating a convoy before escorts could respond. The battery capacity was revolutionary. 3 times the electrical power of Type 7C boats gave enormous underwater range. The Type 21 could travel submerged at 5 knots for 2 to 3 days before requiring battery recharge, which took less than 5 hours using the snorkel. This meant boats could submerge far beyond the Bay of Biscay from French bases, eliminating the Valley of Death where Allied aircraft had slaughtered surfaced U-boats during transit. The hull design embodied hydrodynamic principles that would define submarine architecture for decades. Gone were the protruding features that created drag on conventional boats. The deck gun was eliminated. The conning tower, or sail, was streamlined into a low-profile structure. Dive planes were made retractable. External railings were minimized. The result was a teardrop shape that slipped through water with minimal resistance. This allowed the high underwater speed that made Type 21 boats genuinely dangerous. They could sprint into attack position while submerged, eliminating the need to surface and reveal their location to radar. They could outrun most destroyer escorts while underwater, making pursuit nearly futile. They could dive to 150 meters, safely beyond the depth settings of most Allied depth charges. Older boats typically dove to 80 meters maximum. The deeper diving capability provided both defensive protection and tactical flexibility. The sensors were equally advanced. A sophisticated passive sonar system, far more sensitive than equipment on conventional boats, allowed Type 21 commanders to detect and track targets without using active sonar that would reveal their position. The fire control system could calculate accurate firing solutions without periscope observation, allowing attacks to be executed entirely by sonar bearings. This eliminated the need to raise the periscope, which created a wake detectable by sharp-eyed aircraft observers or increasingly capable surface radar. The Type 21 could approach, attack, and escape without breaking the surface. Crew accommodations were dramatically improved over previous U-boat classes. 57 men rather than the 44 crammed into Type 7C boats. The additional space allowed actual bunks for each crew member rather than hot bunking, where off-duty sailors shared bunks with men on watch. A freezer prevented food spoilage on extended patrols. Showers and improved ventilation made life aboard marginally more tolerable. Air conditioning and recycling systems allowed longer submerged operations without crew incapacitation from carbon dioxide buildup or heat exhaustion. These improvements were not luxuries, they were operational necessities. A submarine designed for extended underwater operations required a crew capable of functioning effectively after days submerged. Proper rest, adequate food, and basic hygiene directly impacted combat effectiveness. The Type 21 represented German recognition that crew welfare was a weapon system deserving equal attention to torpedoes and engines. The production plan was as revolutionary as the submarine itself. Rather than constructing boats sequentially from keel up in traditional shipyards, the Type 21 would be built in prefabricated sections at factories throughout Germany, then transported to shipyards for final assembly. 9 major sections would be manufactured independently. Section 1 contained the bow torpedo room, with its 6 tubes and 23 torpedo storage. Section 2 housed the officers' quarters and command center. Section 3 contained crew quarters and galley. Sections 4 and 5 held the massive battery compartments, each containing banks of high-capacity cells, providing the electrical power that defined the Elektroboot concept. Section 6 held the diesel engines and electric motors. Section 7 contained additional machinery and storage. Section 8 housed the aft torpedo room, though this was smaller than the bow room. Section 9 was the stern section with rudder and propeller assemblies. This modular construction offered multiple advantages. Factories with no shipbuilding experience could manufacture sections using automobile-style assembly line techniques. This multiplied production capacity beyond the limitations of traditional shipyards. Final assembly required only 8 to 12 weeks in the shipyard, rather than 12 to 18 months for conventional construction. This meant shipyard slipways could produce boats 6 to 7 times faster than traditional methods. Albert Speer, Reich Minister of Armaments and War Production, committed Germany's industrial resources to the program with enthusiasm bordering on desperation. Target production was 3 boats per week, 150 per year. If achieved, this rate would produce more submarines than Allied forces could sink, finally reversing the attrition mathematics that was bleeding Germany's naval forces to death. The first Type 21, U-2501, was laid down on April 3, 1944, launched on May 12, and commissioned on June 27. From first steel to commissioned boat in less than 3 months seemed to validate the modular construction concept. Propaganda films showed sections moving down assembly lines, while announcers proclaimed the Elektroboot would restore German mastery of the Atlantic. Dönitz visited construction facilities personally, emphasizing to workers that every day of delay meant U-boat crews dying in obsolete boats. The urgency was palpable and entirely justified. But the prefabrication system that looked elegant on paper revealed catastrophic flaws in practice. Sections manufactured at different factories did not fit together properly during final assembly. Bulkheads from one factory were millimeters off from connecting sections built elsewhere. Pipework didn't align. Electrical conduits terminated in wrong locations. Welding quality varied wildly, depending on which subcontractor performed the work. Some companies had minimal experience with submarine construction standards, producing sections that met general specifications but failed under the stresses of deep diving. The quality problems were not mere inconvenience. They were life-threatening defects that required complete disassembly and reconstruction. Boats arriving at shipyards for final assembly had to be stripped down, inspected, and essentially rebuilt. The theoretical 8 to 12-week final assembly stretched to 6 months or more as workers corrected manufacturing defects that should never have occurred. Pressure hulls leaked, hydraulic systems failed. Electrical systems short-circuited. Diesel engines proved underpowered, limiting surface speed and extending battery recharge time beyond acceptable parameters. The sophisticated hydraulic torpedo reload system was extraordinarily complex, with critical components located outside the pressure hull, where they were vulnerable to corrosion and depth charge damage. Post-war assessment by Allied naval engineers would conclude the hydraulic system was poorly designed and unreliable in combat conditions. The snorkel was badly designed and difficult to use in rough seas. Waves washing over the snorkel head would trigger automatic valves that cut air supply, creating dangerous pressure fluctuations inside the boat. Crews called it the snorkel cough, as pressure changes caused painful ear popping and occasional nausea. In severe conditions, the snorkel was unusable, forcing boats to surface and expose themselves to radar detection. 118 Type 21 boats were completed before the war ended. Of these, only 4 were actually combat-ready, meaning all systems functioned reliably and crews were trained to operational standards. The remaining 114 boats were in various states of mechanical unreliability, requiring weeks or months of additional work before they could be trusted in combat. It was a catastrophic failure of production engineering. Germany had committed enormous resources, including scarce steel, skilled labor, and industrial capacity desperately needed for tanks, aircraft, and artillery. In return, they received a handful of submarines that arrived too late to affect the war's outcome. The few Type 21 boats that did become operational demonstrated both the design's potential and the futility of technological innovation, divorced from strategic reality. U-2511, under Corvette Captain Adalbert Schnee, completed working-up exercises in the Baltic between September 1944 and March 1945. Schnee was one of Germany's most decorated and successful U-boat commanders. Knight's Cross with oak leaves. 21 merchant ships totaling over 90,000 tons were sunk during 12 previous patrols in conventional boats. 2 years on, Dönitz's personal staff, planning convoy operations. If anyone could extract maximum performance from the revolutionary submarine, It was Schnee. On March 16, 1945, U-2511 departed Kiel as part of a combat flotilla, the first Type 21 to do so. She headed to Norway, conducting deep-diving trials and final system checks. On April 30th, as Adolf Hitler committed suicide in Berlin, U-2511 departed Bergen for her first and only combat patrol. The intended destination was the Caribbean, where the boat would be tested under all operational conditions. On May 1st, she made her first enemy contact. Details remain fragmentary. On May 4th, she received Dönitz's ceasefire order. Hours later, she detected the British cruiser HMS Norfolk with destroyer escorts. Schnee's log claims he approached to 500 meters undetected, simulated a perfect attack, then withdrew. Post-war analysis casts doubt on these claims. Records suggest Schnee overclaimed successes throughout his career, reporting 50% more tonnage sunk than cross-referenced records confirm. HMS Norfolk's logs show no ASDIC contact with any submarine on May 4th. British naval officers, when later told about Schnee's claimed approach, were skeptical that a submarine could close to point-blank range without detection. The truth likely lies somewhere between complete success and complete fiction. The Type 21 was genuinely quiet and fast underwater. It's plausible Schnee detected the cruiser and manoeuvred for an attack position. Whether he actually closed to 500 meters undetected is unprovable without corroborating British records, which don't exist. Regardless, the encounter was meaningless. The war was over. 2511 returned to Bergen and surrendered to British forces without firing a shot in anger. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The second and final Type 21 combat patrol was conducted by R-3008 under Captain Lieutenant Helmut Mansek. She departed Kristiansand, Norway on April 1, 1945, and surrendered at sea on May 8 without engaging any enemy vessels. 2 boats, 2 patrols, 0 torpedoes fired, 0 Allied ships sunk. This was the operational legacy of Germany's revolutionary submarine program. 118 boats completed at enormous cost. Thousands of skilled workers were diverted from other war production. Scarce materials consumed, training programs disrupted as experienced instructors tried to master unfamiliar systems, all for a weapons system that contributed nothing to Germany's desperate defense. The failure was not merely tactical or operational, it was strategic, representing a fundamental misunderstanding of modern industrial warfare. Technology alone cannot overcome overwhelming material and numerical disadvantage. Revolutionary weapons require time for development, debugging, production, and crew training. Time Germany was no longer possessed by 1943, when the Type 21 program accelerated. They had established systematic advantages across multiple domains that individual weapon systems could not overcome. Allied shipyards produced merchant vessels faster than any submarine force could sink them, regardless of how advanced those submarines might be. Allied codebreakers routinely read German naval communications, allowing convoys to be routed around U-boat patrol lines. Allied sonar and radar detection systems improved continuously, with new frequencies and power levels deployed faster than German countermeasures could address them. Allied industrial capacity allowed experimentation and failure at scales Germany could not match. If a weapons system didn't work, it was scrapped and replaced with something better. If production encountered problems, additional factories were built. The gap was not merely quantitative but qualitative, representing different approaches to waging industrial war. Most critically, the Type 21 could not solve the fundamental problem facing German submarine operations by 1944. Without long-range patrol aircraft to detect convoys and fix positions, submarine commanders relied on chance encounters or intelligence from naval communications. Hermann Göring's jealous control of the Luftwaffe meant U-boats operated without adequate air reconnaissance. Patrol lines of submarines strung across probable convoy routes frequently missed targets entirely. The vast Atlantic absorbed 30 or 40 U-boats as if they were insignificant specks. Even with 150 Type 21 boats, assuming all were operational and combat-ready, the mathematical probability of intercepting convoys remained low. Finding targets was harder than sinking them. No amount of underwater speed or battery capacity solved the search problem. The revolutionary submarine arrived into a strategic environment where it was irrelevant. By April 1945, the Battle of the Atlantic was long over. Convoys moved across the ocean in numbers that dwarfed anything seen in previous years, supplying the armies liberating Europe. Allied air coverage was so complete that surface ships could sail independently without convoy protection in many areas. The electromagnetic spectrum was dominated by Allied radar at multiple frequencies. The Type 21's stealth advantages meant nothing when convoys could simply sail around known U-boat positions based on communications intelligence and direction-finding networks. Germany surrendered on May 8, 1945. Of the 118 Type 21 boats completed, 11 were operational in Norway, with several more at German ports. 81 were scuttled by their crews rather than surrendered. The symbolic rejection of defeat, echoing the scuttling of the High Seas Fleet at Scapa Flow in 1919, was a meaningless gesture, given the war was irrevocably lost. Allied powers divided the surviving boats among themselves. 1 to France, 2 to Britain, 4 to the Soviet Union, 2 to the United States. Each victor wanted to examine the technology and extract lessons for future submarine development. The irony was considerable. The Type 21 design that arrived too late for Germany became the foundation for post-war submarine development by every major navy. The Soviet Whiskey class, the American Tang class, the British Paupers class, the Swedish Hagen III class, all derived features from the Type 21's revolutionary design. The streamlined hull form, the emphasis on underwater performance over surface speed, the high-capacity batteries, the sophisticated sensors. These became standard submarine characteristics for decades. W-3540, later raised and refitted as the research vessel, Wilhelm Bauer for the West German Bundesmarine, served until 1982 before becoming a museum ship in Bremerhaven. She survives today as the last Type 21 afloat and the last unmodified World War II German U-boat accessible to the public. Visitors walking her narrow passages see the cramped bunks, the banks of batteries filling sections 4 and 5, the 6 bow torpedo tubes that never fired in combat. The boat is a monument to technological sophistication, rendered irrelevant by strategic failure. American submarine commander Everett Steinmetz, who evaluated captured Type 21 boats for the United States Navy, later wrote about the experience. The boats had admirable features and represented genuine innovation in several areas, but they also demonstrated serious flaws that combat would have revealed brutally. The hydraulic systems were vulnerable and complex. The diesel engines were underpowered. The construction quality was poor due to rushed production. Most critically, the design could not have changed the war's outcome, even if deployed a year earlier in larger numbers. The Allies had already solved the submarine problem through combined advances in radar detection, sonar tracking, air coverage, convoy tactics, and overwhelming ship production. Advanced submarines would have forced tactical adaptations, but could not have reversed the strategic balance. The human cost of Type 21 production extended far beyond German naval personnel. The Valentin submarine factory, built near Bremen between 1943 and March 1945, was intended to be the ultimate bomb-proof assembly site for the Elektroboot. The massive structure measured 426 meters long and 97 meters wide, with reinforced concrete walls 4.5 meters thick. Construction required 650,000 cubic yards of concrete, poured by workers who had no choice about being there. Between 10,000 and 12,000 forced laborers, including concentration camp prisoners, prisoners of war, and slave workers from occupied territories, were used to construct Valentin. They worked 12-hour shifts with little food and inadequate medical care under the watch of SS soldiers. Those too sick or too slow were executed, a brutal policy that created labor shortages by 1944, greatly slowing production. The French survivor Raymond Portefeuille later testified about conditions in what were called the iron detachments, responsible for moving steel girders. Assignment to these units was essentially a death sentence. The identity of only 553 victims, mostly Frenchmen, has been confirmed, but the total number of deaths may be as high as 6,000, as the names of Polish and Russian dead were not recorded. The Germans didn't record their deaths because Nazi racial ideology classified Slavic peoples as subhuman, unworthy of documentation. Thousands of men died building a facility designed to produce weapons that would never fire a shot in combat. They perished constructing concrete walls intended to protect submarines from Allied bombs. On March 27, 1945, 20 Avro Lancaster bombers from 617 Squadron RAF attacked Valentine with earthquake bombs. Each Lancaster carried a single massive weapon, either a 5-ton tallboy or a 10-ton Grand Slam. 2 Grand Slams hit the target and penetrated about halfway through the 15-foot thick concrete roof before exploding. The explosions blew large holes in the roof and brought down around 1,000 tons of debris into the chamber below. The facility was 90% completed when damaged and subsequently abandoned. Weeks later, British forces captured the area. Out of the 118 Type 21 boats completed at other shipyards, only 4 were rated fit for combat before the war ended in Europe. Valentine never assembled a single submarine. The forced labourers had died for nothing. Their suffering purchased no tactical advantage, achieved no strategic objective, delayed Allied victory by not one day. The massive concrete structure, built with blood and agony, survived as a monument to the Third Reich's delusional priorities in the war's final years. The production problems that plagued Type 21 construction revealed fundamental failures in German industrial organization under pressure. The schedule called for component work on each hull to be completed in 4 months, with a further 2 months on the slipways at Hamburg, Bremen, or Danzig. The first Type 21, U-3501, was launched at Danzig on April 19, 1944, as a 55th birthday present for Adolf Hitler. The boat was not truly ready, but Speer and Dönitz wanted to impress Hitler. As soon as Hitler's entourage departed, workmen frantically moved in pontoons to keep the U-boat afloat until they could tow it to dry dock. The political pressure to meet arbitrary deadlines, particularly Hitler's birthday, corrupted engineering discipline throughout the program. Plants manufacturing the new boat's sections had no experience in building entire modules. At final assembly yards, workers discovered gaps of as much as 3 centimeters, over an inch, between sections that were supposed to fit with near-zero tolerances. Some of the workmanship was downright shoddy, with bad welds that could prove fatal during deep dives. Submarines depend absolutely on hull integrity. Water pressure, at 150 meters depth, exerts crushing force on every square centimeter of surface. A single bad weld could cause catastrophic failure, imploding the pressure hull in milliseconds and killing the entire crew before they could even register what was happening. By the end of 1944, 64 Type 21s had been commissioned, but that didn't mean the U-boats were ready to deploy. As each boat went through trials, all sorts of defects showed up in the engine superchargers, steering mechanism, advanced torpedo loading system, and snorkel. It may have taken only 180 days to build an Elektroboot, but it took another 120 days to repair all the deficiencies. The theoretical production advantages of modular construction evaporated completely when boats required essentially complete reconstruction after assembly. German industry was expending double the expected labor and time to produce submarines that still didn't work reliably. The hydraulic torpedo loading system, one of the Type 21's most celebrated features, exemplified the gap between design ambition and operational reality. The hydraulic system was unduly complex, and its main elements were located outside the pressure hull, making the system highly vulnerable to corrosion and damage. Locating critical components outside the pressure hull meant they were exposed to seawater under tremendous pressure during deep dives. Salt water and high-pressure hydraulics are incompatible. Corrosion was inevitable. Any depth charge explosion near the boat could rupture hydraulic lines, rendering the entire reload system inoperable. The system that was supposed to give Type 21 boats overwhelming firepower was fragile and prone to failure exactly when it would be needed most, during combat. The submarine's engines were underpowered, which limited surface speed and increased the time required to charge batteries. This created a vicious cycle. Lower surface speed meant longer transit times to operational areas, consuming battery power. Underpowered diesels meant longer charging times, forcing boats to remain near the surface using the snorkel for extended periods. The snorkel was badly designed and difficult to use in rough seas. The automatic head valve that prevented water from flooding down the intake tube would slam shut when waves washed over it, instantly, cutting air supply to the diesel engines. The sudden pressure drop inside the boat was painful and disorienting, causing ear damage, and sometimes rendering crew members temporarily incapacitated. 17 Type 21 boats were destroyed by Allied bombing while in harbour or during trials between December 1944 and May 1945. Each represented thousands of man-hours of labour, scarce materials, and industrial capacity that could have been devoted to weapons that might actually affect the war's outcome. Germany was losing approximately 2,000 tanks per month on the Eastern Front by late 1944. A senior engineer in the naval shipbuilding program estimated that a single Type 21 submarine consumed steel equivalent to 30 tanks. Simple arithmetic revealed the strategic insanity. 118 submarines represented steel for 3,540 tanks. Those tanks, deployed on the Eastern or Western fronts, might have delayed Soviet or Anglo-American advances by weeks or months, buying time for negotiated settlement. The submarines, arriving too late with too many defects, contributed nothing. The target acquisition problem, which neither Dönitz nor his staff adequately addressed, doomed the Type 21 concept, regardless of technical performance. Without long-range patrol aircraft to detect convoys and fix their positions, submarine commanders relied on chance encounters or intelligence from communications intercepts. Hermann Göring's jealous control of the Luftwaffe meant U-boats operated without adequate air reconnaissance. The German naval air arm, despite repeated requests from Dönitz, never received the resources to conduct effective ocean surveillance. Allied convoys covered millions of square kilometers of ocean. Even 150 operational Type 21 boats, assuming all functioned perfectly, represented insignificant coverage of the vast Atlantic. The mathematical probability of submarines randomly encountering convoys was vanishingly small. Finding targets was exponentially harder than sinking them. The most advanced submarine in the world was useless if it never located enemy ships. The Allies weren't static targets waiting for German wonder weapons to appear. Allied anti-submarine warfare evolved continuously throughout the war, with new tactics and weapons deployed at rates German countermeasures couldn't match. Forward-firing Hedgehog anti-submarine mortars, introduced in 1942, allowed escorts to attack without losing sonar contact. The projectiles exploded only on contact, so any explosion confirmed a hit. Acoustic homing torpedoes, deployed by Allied forces in 1943, could pursue submarines attempting to escape. Escort carriers brought aircraft to mid-ocean areas previously beyond land-based air coverage. By 1944, Allied anti-submarine forces possessed multiple overlapping detection and attack capabilities that created defensive networks. Submarines couldn't penetrate consistently. The electromagnetic spectrum remained dominated by Allied technology. Even if Type 21 boats could dive deep and run silent, they eventually had to approach periscope depth to locate targets. Radar could detect periscope vakes. Improved sonar could track snorkel exhaust. High-frequency direction finders could pinpoint any submarine transmitting radio messages. The Type 21's stealth advantages were marginal at best against opponents who possessed comprehensive detection suites operating across multiple frequencies. German scientists and engineers, brilliant as they were, couldn't overcome the cumulative advantages Allied forces had built through years of sustained development and operational experience. The strategic context by 1945 made submarine operations increasingly futile, regardless of technology. After D-Day in June 1944, Allied forces captured the first French Atlantic ports that had served as forward U-boat bases, Brest, Lorient, Saint-Nazaire, La Rochelle, and Bordeaux, all fell to advancing Allied armies between August and September 1944. U-boats operating from German and Norwegian bases faced dramatically longer transit distances to reach operational areas. The Iceland-Faroe Gap and English Channel became heavily mined and patrolled by Allied destroyers and aircraft. Submarines attempting to break out into the Atlantic ran a gauntlet of defensive measures that sank boats routinely. The geography of submarine warfare had shifted decisively against Germany. The few Type 21 boats that did achieve operational status faced a war already lost. By April 1945, when U-2511 and U-3008 conducted their patrols, Germany controlled only disconnected pockets of territory surrounded by advancing Allied armies. Berlin was under siege. The Reich's government had collapsed into competing factions. Training programs were shuttered as bases were overrun. The entire German military machine was in terminal collapse. Submarines, however advanced, couldn't reverse defeat driven by Allied armies numbering millions of men supported by tens of thousands of tanks and aircraft. Corvette Captain Helmut Mansek's patrol in U-3008 demonstrated both the capabilities and the irrelevance of the Type 21. He departed Kristiansand on April 1, 1945, transitioning submerged through the heavily patrolled Norwegian coastal waters. The boat's performance met specifications. Battery capacity allowed extended underwater operations. The streamlined hull form provided good speed and handling. Sensors functioned adequately. But Mansek found no targets. The convoys he sought were either not present in his patrol area or were routed around known submarine positions based on communications intelligence. On May 3rd, shortly after departing Wilhelmshaven, he received news of Germany's imminent surrender. He spotted a British convoy and conducted a simulated attack, then returned to port without engaging. The most advanced submarine in the German fleet had accomplished nothing operationally significant. The post-war evaluation of captured Type 21 boats by Allied naval forces revealed grudging respect mixed with harsh assessment of practical limitations. American submarine commander Everett Steinmetz led technical teams that examined multiple boats in detail. His reports, declassified decades later, acknowledged the revolutionary design concepts while documenting severe execution flaws. The streamlined hull form influenced every subsequent submarine design through the nuclear age. The emphasis on underwater performance over surface characteristics became fundamental to modern submarine doctrine. The high-capacity battery installation demonstrated practical methods for extended, submerged operations. These were genuine innovations that changed naval architecture permanently. However, Steinmetz's teams also identified fatal weaknesses that would have limited Type 21 effectiveness, even if deployed in larger numbers earlier in the war. The hydraulic systems were over-engineered and fragile. The diesel engines were unreliable and underpowered. Construction quality was poor throughout, with welds, pipe fittings, and electrical systems showing deficiencies that would cause failures under combat stress. The sophisticated sensors and fire control systems required maintenance beyond the skill level of average crews, particularly as Germany's training programs deteriorated under Allied pressure. Most critically, the boats lacked strategic purpose. They were optimized for a mission, convoy interdiction, that was no longer achievable given Allied advantages in detection, escort tactics, and overwhelming numerical superiority. Soviet Union received 4 Type 21 boats under the Potsdam Agreement. They commissioned them as B-27, B-28, B-29, and B-100, operating them for years while reverse engineering the design for indigenous production. The Whiskey-class submarine, built in massive numbers through the 1950s and 60s, incorporated Type 21, features adapted to Soviet manufacturing capabilities and operational doctrine. Over 230 Whiskey-class boats were constructed, becoming the backbone of Soviet submarine forces during the early Cold War. The design Germany couldn't produce in meaningful numbers became the foundation for the largest submarine fleet in history. The United States acquired U-2513 and U-3008, Both underwent extensive testing in Atlantic waters. President Harry Truman visited 2513 in November 1946, observing a dive to 440 feet. The submarine's performance impressed American observers, validating concepts that would influence the Tang-class design commissioned in the 1950s. U-2513 was eventually sunk as a target in October 1951. U-3008 served in various research capacities until sold for scrap in September 1955. The technology German crews never used in combat became the basis for American submarine development for a decade. Britain took U-3017, commissioning it into the Royal Navy as HMS N41. The boat underwent testing until scrapped in November 1949. British submarine designers incorporated Type 21 concepts into the Torpedoes-class boats of the 1950s, acknowledging German engineering while correcting identified flaws. The international distribution of captured submarines ensured that Type 21 technology influenced global submarine development despite its operational failure for Germany. U-2540, scuttled by her crew in May 1945, was raised in 1957 and refurbished for service with the West German Bundesmarine. Renamed Wilhelm Bauer, she operated as a research vessel until retirement in 1982. Today she serves as a museum ship at the German Maritime Museum in Bremerhaven, the last surviving Type 21 and the last unmodified World War II German U-boat accessible to the public. Visitors walking through her narrow passages see the revolutionary design that arrived too late: the streamlined hull, the massive battery banks, the 6 bow tubes that never launched torpedoes in anger, the sophisticated sensors that detected no enemies. She is a monument to technological sophistication, divorced from strategic reality. The final accounting of the Type 21 program reveals one of history's clearest examples of innovation failing to overcome structural disadvantages in industrial warfare. Germany diverted enormous resources to develop and produce revolutionary submarines during a period when those resources were desperately needed elsewhere. The steel consumed by 118 submarines could have built thousands of tanks. The skilled labor assembling boats could have manufactured aircraft or artillery. The engineering talent debugging hydraulic systems could have improved existing weapons. The forced laborers dying at Valentin could have been building fortifications or producing ammunition. Every hour and every mark invested in Type 21 boats was stolen from weapons systems that might have delayed defeat, buying time for political settlement, or at minimum allowing more German civilians to escape Soviet occupation. The lesson was harsh but unambiguous. Advanced technology cannot overcome strategic disadvantages rooted in industrial capacity, geographical position, and cumulative advantage built through sustained effort. The Type 21 boats were genuinely revolutionary, incorporating concepts that defined submarine warfare for 50 years after the war. But revolutionary design means nothing if boats can't be produced in sufficient numbers, with adequate quality, deployed in time to affect outcomes, and supported by the larger military and industrial systems required for effective employment. Germany in 1944 lacked all these prerequisites. The Elektroboot program was desperation masquerading as innovation, hope substituting for realistic assessment. Admiral Dönitz's memoirs, published years after the war, acknowledged the program's failure while defending the decision to pursue it. He argued that without revolutionary submarines, the U-boat campaign was finished, so attempting the Type 21 represented rational choice given limited options. This logic ignored the alternative of accepting that the submarine war was lost and reallocating resources to weapons that might actually delay defeat on land. Dönitz couldn't admit, perhaps even to himself, that his chosen weapon, the submarine force he had built and commanded, had become strategically obsolete. Accepting that would mean accepting that his life's work had failed. So he pursued wonder weapons that consumed resources while delivering nothing. The psychological impact on German crews was devastating, in ways different from the demoralization caused by Allied radar superiority. The Type 21 represented hope, the promise that German technology would restore superiority stolen by Allied mass production. Crews training on the new boats believed they would finally possess weapons matching or exceeding enemy capabilities. The boat's technical problems, the endless delays, the quality failures, the mounting evidence that even perfect Type 21s couldn't affect the war's outcome, shattered that hope completely. They weren't losing because Allied forces were more numerous or more determined. They were losing because their own leadership had squandered resources on weapons that couldn't work, pursuing technological fantasies while real needs went unmet. Herbert Werner, who survived the war and wrote extensively about his U-boat experiences, reflected bitterly on the Type 21 program. He saw it as emblematic of Third Reich dysfunction in the war's final years. Brilliant engineers and brave crews, working under impossible conditions with inadequate resources, attempting to implement half-finished designs that couldn't possibly achieve strategic objectives even if they worked perfectly. It was desperation theatre, performing innovation for audiences who needed to believe victory remained possible. The submarines were props in a propaganda narrative that bore no relationship to operational reality. The stark numbers tell the complete story. 118 Type 21 boats completed, 4 combat-ready, 2 conducted patrols, 0 Allied ships sunk, 0 strategic impact. Thousands of forced labourers dead constructing facilities that never produced operational submarines. 17 boats destroyed by Allied bombing while in harbour. Enormous quantities of steel, labour, and engineering talent consumed for weapons that fired no torpedoes in anger. Meanwhile, Allied forces crossed the Rhine, captured Berlin, and ended the war in Europe through conventional military operations that German wonder weapons couldn't delay by a single day. The Type 21 remains a cautionary tale about the seductive danger of technological solutions to strategic problems. When military forces face overwhelming disadvantage rooted in numbers, geography, resources, and operational skill, pursuing revolutionary weapons becomes tempting. Such weapons promise to restore parity through innovation, allowing smaller forces to defeat larger ones through qualitative superiority. This promise is almost always false. Modern warfare is systemic, depending on industrial capacity, logistics, training, intelligence, coordination across multiple domains, and sustained effort over years. Individual weapons, however advanced, cannot overcome systemic disadvantage. The side with better submarines might win local engagements, but loses campaigns to the side with more ships, more aircraft, better intelligence, superior logistics, and the industrial capacity to replace losses while improving capabilities continuously. Germany's wonder weapon programs, the Type 21 submarine, the Messerschmitt Me-262 jet fighter, the V-1 flying bomb and V-2 ballistic missile, absorbed resources that conventional weapons might have used more effectively. All arrived too late, in too few numbers, with too many technical problems, facing enemies who had already secured decisive advantages. They represented desperation disguised as innovation, hope substituting for strategy. The Kriegsmarine thought the Type 21 was unstoppable. They were correct about its revolutionary design. They were catastrophically wrong about its strategic relevance. It fired 0 torpedoes before surrender, a perfect encapsulation of Germany's final years, when brilliant engineering and desperate courage couldn't overcome the mathematics of industrial warfare. The story ends where it began, with Adalbert Schnee in U-2511 approaching HMS Norfolk on May 4, 1945. He possessed the most advanced submarine in the world. He held firing solution on a valuable enemy warship. He could have attacked, achieving the Type 21's first and only combat success. Instead, he withdrew, acknowledging the reality his superiors had denied for years. The war was over. Germany had lost. No technological miracle would change that outcome. The revolutionary submarine that was supposed to win the Battle of the Atlantic fired nothing, sank nothing, accomplished nothing. It served only as evidence that innovation without strategy, technology without resources, and hope without realistic assessment produce only expensive failures. The Kriegsmarine's wonder weapon became a monument to desperation, a cautionary tale about mistaking technological sophistication for strategic effectiveness, a reminder that wars are won not by the best weapons, but by the side that can produce adequate weapons in overwhelming numbers while maintaining the systematic advantages that define military effectiveness in industrial age warfare. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.